Welcome to Neutral Podcast, where we discuss paving the way to a regenerative tomorrow. I'm Nate Helbach, your host, founder, and CEO of Neutral, a regenerative real estate development company. Join us each week as we host world-renowned guests and explore the dynamic landscapes of real estate development, alternative investing, sustainability, forestry, urbanism, and design. Learning how to make places for people. Welcome back to the Neutral Podcast. Today I'm calling in from the forest of the North Woods of Wisconsin, and I'm joined by Josh Dortzbach, who is the founder of Forefront Engineering. Thanks for joining the show, Josh.
Absolutely. Thanks for having me, Nate.
Just a little background on Josh before we get started. Josh has over 27 years of structural engineering experience and started Forefront Structures 17 years ago. He brings a wealth of knowledge in mass timber engineering and construction. He also worked on an impressive list of historical adaptive reuse projects, emphasizing structural integrity, including Chicago Athletic Association, which we're going to talk about a little bit more today, and also 1K Fulton Google headquarters and the Salt Shed in Chicago. Josh has a background in both structural engineering and liberal arts that makes him a lifelong student of projects and people. He received his liberal arts degree from Wheaton College and civil and structural degrees from Illinois Institute of Technology. Josh strives for technical excellence, artistic creativity, and practical application. Today we're going to talk a little bit about Josh's background, and then we're going to get into historic adaptive reuse, mass timber, and then Josh has some exciting news that I won't spoil yet, but we're going to end with that and then maybe do another podcast to talk about it. But Josh, if you could just open up and give our listeners maybe a little background on yourself, where you came from, where you went to school, how you got into engineering.
Yeah, thanks, Nate. Thanks for having me on today. It's great to interact a little bit further on this. It's been great to interact with you on multiple levels, but especially here now today as well. I actually grew up in East Africa in the country of Kenya, but I suppose my story should back up a little bit before that even. I was nearly born in Ethiopia. My parents were missionaries in Ethiopia. My mom was actually kidnapped by the Ethiopian Liberation Front 50 years ago when she was pregnant with me. And then we were forced to return back to the United States. And I was born in Philadelphia. My dad was going to Westminster Theological Seminary at the time. And about 1980, we moved back to Africa. And that was sort of the beginning of my formative years at age 6, living in a third world country. I spent time in the capital of Nairobi for a lot of my time while I was there, but I also spent a lot of time in rural Africa, completely off-grid. That's, I think, really where my affinity for sustainability began, was living completely off-grid, no running water, no electricity. I have all kinds of stories I could share with you about what that was like. But I spent quite a bit of time there, and then moved back to the United States to finish high school, lived in Southeast Georgia, North Florida, in a little town called Brunswick, Georgia. After that, I moved up to Chicago to attend Wheaton College for my liberal arts degree, and simultaneously to Illinois Tech. They have a dual degree program where you basically get one of each. And for me, that was a great place to land. I would say that a lot of times I tell people my engineering degree is what got me a job, but it was my liberal arts degree that makes me good at my job. And so that time that I spent in East Africa, in Southeast Georgia, and then here in the Midwest has really been informative to my journey towards engineering. I suppose I should also add that I worked as a trade carpenter from the time I was about 14, 15. My dad, although he was a pastor, was also a carpenter. And so he taught me how to swing a hammer, how to do fine woodworking. And my love for timber really grew out of that early on. So I found my way into engineering a little bit by trades, a little bit by DIY on the weekends. And then it was my physics classes in high school that really piqued my interest in forces and how they interact with our built environment, what we can do with that. And as I progressed in that, and actually, a lot of people come to engineering because they love math and science. That was not my story at all. In fact, I almost dropped out of engineering because I didn't like math and science as much as my colleagues did. When I finally realized that math and science were tools for me to do what I really like to do, which is to solve problems then it became much easier for me, and I found myself in the right spot. So that's a little bit about my journey from childhood in a third world country to today. My wife and I have 4 boys. We live in the south side of Chicago. Been there for 26 years now. And 3 of my 4 are in college, and the 4th is in high school now. So that's a little bit about my background.
Nice. I have to ask about the kidnapping. Can you tell the story of what happened?
Yeah, I can. If you want to read about it, you can go read my mom's book, my dad's book. So they were teaching at a Bible college in Eritrea, and this is during the civil war in Eritrea, in Ethiopia. And at one moment, the ELF, the Liberation Front, came into the front of the hospital my mom was working in. My mother was a nurse. They grabbed her, took another woman with her, left, and ran through the mountains. The other woman, unfortunately, could not keep up with them, and she was gunned down. And my mom was a little afraid at the time, understandably. She had me as about 5 months old at the time in utero. And it was a long ordeal over about 30 some days, at the end of which she was released without conditions. But you can go read that story for another day in my parents' book, which I can give you a copy of if you're interested. It's actually why my name is Joshua, which means the Lord of Salvation. So that's a little bit of fun fact background.
Wow, that's crazy. What's the name of the book? I'll link it in the show notes too if anyone wants to read it.
It's pretty generic. It's called Kidnapped by Carl and Debbie Dortzbach. Not the other Kidnapped you're well familiar with.
Very, very.
You can find it online if you Google stuff, articles and news clippings that came out from 1974 when she was released.
Wow, now you're dating yourself as well.
Yeah. Well, I told you I was 50 at the beginning of it, so yeah.
So after the kidnapping, your parents moved back to Philadelphia. And then after Philadelphia, how do you land in Chicago? Is it just Wheaton or?
No. Yeah. So I went from Philadelphia back to Kenya. So my parents went back to overseas as missionaries to Kenya. So I lived my formative years there, came back to the United States because I wanted to go to Wheaton College. And that was via high school. I finished in Southeast Georgia. So yeah, I found myself back in Chicago because I wanted to go to Wheaton College. I wanted to do a dual degree program. I knew I wanted to pursue engineering. Wheaton College did not have an engineering program, but they had this dual program. We ended up with 2 degrees in 5 years. And so that's the course that I took.
Interesting. Cool. Yeah. Okay, well then moving into our next segment, we won't belabor the point about kidnapping, but if you want to read more, I'll link it in my show notes. But talking a little bit, Josh, just about historic and adaptive reuse projects. This has kind of been a big crave, I'll say, over the last 3 to 4 years, especially in real estate developments, and a lot of people talking how can we kind of take all these old office 1980 stock and convert them to multifamily. And I'd just love to hear kind of your opinion on that from both an engineering perspective and having kind of lived these projects in Chicago.
Yeah, it's a great question, Nate. So I tell people often that at Forefront Structural Engineers, we do sort of 3 things really well: mass timber from small to tall, adaptive reuse, really messy, complicated projects like a couple I'll describe here, and then tall post-tension work, which actually goes integrally with our tall mass timber work as well. So the adaptive reuse is an interesting space. When you talk about sustainability, adaptive reuse is one of the best ways that we can minimize additional carbon. And so if we're building new, mass timber is a great way to do that. If we're going to save existing buildings, we can actually minimize some of our carbon footprint there as well. So I'm a big believer in adaptive reuse from a sustainability standpoint. I'm also interested into it because I love the history of old buildings and how they did things 100, 200 years ago, and how we can learn on that, iterate on that, and get better at that in what we do today. So yes, they are complicated. A lot of people stay away from them because of that. But we've found that there's actually a pretty good recipe for success with them. And it starts with really early feasibility studies where you have to get in. I mean, the early questions that we often have include, do I have any original drawings? Is there any testing that was done on the building? Is there any history to the building? And that's often what we get into very, very early. Not that dissimilar to new construction projects where we're asking, do we have geotech report? Do we have any, all those early questions that we might ask. But deeper, because you now have to spread your knowledge base across codes from 150 years ago or 100 years ago and understand the implications and the evolutions of codes, what they mean today, how it impacts a change of use for a building. So if we're taking an office building, converted into a hotel, what does that mean? If we're taking an OLAF, and this is happening a lot in Chicago right now in cities around the country where there's less and less people in offices and they're repurposing those buildings as residential, for instance. Chicago's got some work like that they're looking at right now. Or in our case, at the 1K Fulton and the Google property here in Chicago, that had been a 10-story cold storage building, literally was a block of ice for 100 years. And we came in and thawed it out and converted it into high-tech space for Google. So lots of stories they could tell about that. And even I think there's some time lapses from our thawing of the building online that you can see. So an understanding of what to do with buildings like that, how to approach it. So that early feasibility study, really important. And then I'm a big believer in iterating very quickly on the front side of, okay, what are limitations? You know what the rules are now. And now how can I work within those framework? And so from an engineering standpoint, there's a lot of opportunity there to iterate. I think from a development standpoint, there is too, but you have to know what the other levers are, right? So like TIF financing is a big deal on adaptive reuse projects. Are you going to go after the historic tax credits or not? Is there anything else that could offset that? The biggest thing is knowing the unknowns and how to navigate around those or how to quantify them, because a lot of people get off track with budget busts that happen because they didn't think about what else might be a problem, right, in the building. And that can be a nightmare if you don't know how to treat it right, which is why we're a big believer in navigating those costs early and holding a healthy contingency for the inevitable unforeseen conditions that come up. So yeah, so adaptive reuse projects have definitely been a part of what we do. Is something I enjoy doing, leading really from a sustainable standpoint, but also from an interesting historical standpoint of understanding how things were done. I'm in the middle of, this is not I guess it is adaptive reuse. I'm redoing my home right now. It was built in 1870 and I did it 25 years ago. I'm doing it again now. And as a carpenter, I'm the one doing the reframe work, and just to see beautiful mortise and tenon details that you would never see today, right? I mean, hopefully we get back to some of that with our CNC capabilities and mass timber. But, up until the last 2 decades, you would see that again because you go get a Simpson hanger, right, from Home Depot and slap it together. So just even that is interesting when you go back and look at old buildings, how they were put together, what you can pull out from that and integrate into what we do today. And the last thing I'll say on that, and this is, again, pulling back to my history, I'm a big believer in going from the first world to the third world and back to the first world. So what I mean by that is that when I visit Africa, my home country, or I visit this summer, I went to South America, went to Ecuador with my family to the rainforest. And when I interact with places of the world that are not as, I guess, on paper advanced as the Western world, technologically or otherwise, there's a lot of things that come up that you see, oh, wow, if that wasn't a constraint, this is how they would build that, or they do it again and again and again. So I like taking some of the ideas we might have in the first world and filtering them through the third world, because one of the things I saw many, many times where you could have a great idea, and if you take it to somebody who you don't communicate very well with, and they take that and say, well, that's great for you, but doesn't work for me. So rather than forcing ideas on people, to learn from them collaboratively in a way that you can then bring that back home or to your office or wherever and change how you approach it. The same thing happens, I think, in adaptive reuse. As we look back at history, like what was done there, we don't have the benefit of going and talking to the architects and engineers and builders from those days, but we have their drawings, we have their history of what they did. We can learn from that, and then we can layer that back into the first world, or the modern world in this case. We do. So that's a little bit of why I appreciate adaptive reuse work.
Do you think from like a development perspective, they're necessarily like cost effective? Because I think one of the things we've seen, and we've done a few studies in one small adaptive reuse project in Madison, and the one we're doing in Madison is, I mean, just a nightmare because the whole structure is basically failing.
Yeah.
But like we even did studies on a few in San Francisco and Oakland, and both had to have huge like structural basically upgrades in order to actually make it viable. Because the office code versus residential is so much different.
Yeah.
From that perspective, do you think it's affordable?
It really depends. That's why that early feasibility study is so instrumental in determining that, because there are absolutely projects like you described that would not work at all, right? Or that would take so much money, it just wouldn't make sense on your ROI. So I look at that early feasibility, like kick the tires, get an engineer who knows what they're talking about when it relates to, hey, what's the sniff test on this? Does it make sense or not? But on the flip side, like we've taken, 4-story buildings when here in Chicago and added 4 stories on top of it with almost no foundation strengthening, right? That was because we were able to do early studies to prove what could happen, and we saved a ton of money. Or I've looked at numerous projects now around the country where we take an old parking garage that a city of XYZ town owns. A municipal garage is historically underutilized in a lot of cities, especially in the Southeast, and look at putting a mass timber residential building on top of it. Well, now you have parking built into the base of it. If we can bring a new concrete core down through the building and then put resi above it, and with minimal or even some foundation strengthening, that's a really interesting play right now that integrates mass timber into adaptive reuse. Or another one, and we're not involved with this, but the Thompson Center here in Chicago is undergoing renovation right now as another Google headquarters. And besides the fact that building, and I'm sure I'll offend some viewers, but it is ridiculously ugly. When you go inside, it has this huge atrium, which is kind of interesting, but how could you adapt that space in a different way? And I think that mass timber is actually a natural material for us to use in adaptive reuse because it's lighter weight, it's easily modifiable, right? And you can put it through, and I'm sure we'll get into this later, but like a DFMLA approach where you actually are thinking about manufacturing as you're doing it. So that's a long-winded way of saying do your homework early, do it quickly, and fail quickly. So in other words, spit out very, very early, is this actually something that we can make money at or not? If not, I mean, there's plenty of buildings that we end up having to tear down and build new on that site. But I think if you do the hard work, you can find the ones that are worth saving.
Yeah. No, that's a good segue into this next segment about mass timber. Before we get into design for manufacturing assembly,
yeah,
MLA, what kind of intrigued you about mass timber construction? Because I think, like, from my perspective, it's kind of an interesting business play for an engineer to say, I'm going to start engineering mass timber, especially, I mean, 5 years ago when you started, or I think that's when you started, there really wasn't any industry around mass timber. So from a business case, it probably didn't make a lot of sense because the code wasn't caught up. There wasn't a ton of mass timber buildings. And so you were getting educated about a material that really developers back then weren't using. Now it's starting, I want to say, to become vogue, but not there yet. It's at like the precipice of becoming vogue. So what intrigued you about learning more about the material and designing with it?
Yeah, great question. Well, the first was I am a carpenter, right? And so the hands-on nature of mass timber was always interesting to me. And I would go back and say, really, I mean, we've been working in heavy timber for decades. Like that's not new. So wood, and we did a lot of stick build stuff too. We still do some of that. But the idea of big wood, we've been working in big wood for quite a while. What's new is the idea we take a bunch of little round pieces and cut them into rectangular pieces and glue them together and make even bigger materials. So that part is new, which is really more about the manufacturing and sustainable forestry and how we mitigate that process, or I should say champion or steward that process. So my interest in mass timber really began even a little bit before 5 years ago. We were looking at a project in Chicago in the West Loop area that was an adaptive reuse project, and it was a heavy timber building. And we were looking at ways to add on top of it or on the side of it. And we started looking at cross-laminated timber as an option to get farther spans because a typical heavy timber building is maybe 15 to 20 foot grids, which is not that far off of a lot of tall mass timber today. But the decks are typically, heavy purlins every 4 feet with heavy tongue groove decking. And even before that, I actually designed heavy timber glulam building in Chicago. Gosh, it was probably 14 years ago now. It was a 4/1. It actually was the first taller residential mass timber in Chicago, even though other people point to other things. That was the first one. We got the first one through. We had a steel frame podium with 4 stories of glulam column and girder, but the decking was tongue and groove decking. So that part was a little more traditional. So I've had my hands in it for over a decade. What changed was all of a sudden when manufacturers in Europe and the United States started looking at CLT and what that could unlock with possibilities. And so for me, that interest went and peaked up even more. I had taken this adaptive work and then my carpentry background, and then now the ability to take something that's not limited to, a 2 or 3 story building, but we can do a 30 or even a 50-story building, right? So the idea that we can actually stretch that boundary. And so for me, the business case became looking around, and this is a little bit deeper in broad base, but I've never wanted to be content to like just live in the present scenario. So I remember very strategic moment about 7 years ago now saying, we need to spread way beyond Chicago, and we need to spread our material and our palette into other areas, including mass timber, because this is a wave that is coming, and we've always been trying to keep our eyes on the next wave that's coming. I don't think this is a fad that's coming and going. I think it's here to stay and for a long time. But so for me, actually, the business case was pretty clear based on my background, as well as looking at current opportunities that could overlay to that. And then when I saw the manufacturing world coming on board with supply chain that would actually allow us to do something, so now you could actually procure material, it wasn't just an idea, then that started to make a difference for us.
And when you say it's not just a wave, you think it's here to stay. What do you mean by that? Like, why do you think the material is here to stay, and how is it better than maybe its counterparts like steel and concrete?
Yeah, I mean, honestly, it's renewable, right? I mean, if you look at the 4 basic building blocks that we use today, steel, concrete, masonry, and wood, that it is the only one that's fully sustainable, that renewable. And now, of course, embedded with that is a necessary approach to sustainably foresting, and not clear cutting. There's a lot of misconception around what exactly that looks like, but that's why I think it's here to stay. When you focus on ways to reduce carbon in our built world, which accounts for such a large percentage, this is one of the best ways to do it. Now, I think the steel and concrete guys have lots of opportunity to grow in that, and I think they will. I think that the concrete guys are going to continue, and folks are going to continue to innovate in that space. But when you walk into a mass timber building, number one, the frame goes up incredibly fast, and we might touch on that a little bit later. Number two, the sustainable abilities around that or properties around that. And then number three, you can't deny the biophilic benefits of a mass timber building when you walk into it. You feel different, right? And I know I'm preaching the choir a little bit, but those are reasons why I think it's here to stay. And people are adopting. We're starting to see on our multifamily residential projects a high premium on rent for mass timber buildings, which is offsetting what's currently a premium for that. I'm sure we'll get into that a little bit later too. But those are all reasons why I think it's going to stay. And I think it's going to go way beyond housing, right? I think it's going to, you've already seen it in office space, right? With the Heinz development stuff that they do T3. The building I was doing in the West Loop that introduced me to mass timber was an office building. So I think those are all reasons why it's here to stay.
Yeah, I mean, talking about the cost competitiveness of mass timber, I mean, right now, a lot of the studies that we've done internally just on our projects, it's definitely more expensive. Not much, but there's definitely a cost premium. How do you think mass timber, and I think for more mass adoption, this needs to happen, but how do you think mass timber becomes either cost competitive or cost negative compared to its counterparts like steel and concrete?
Yeah, well, I think number one is education, helping people understand what it is, how you design with it, how you build with it, how you procure it. It's still a little bit of the Wild West, and I like that about mass timber. So knowledge is one of those things. Groups like Woodworks are doing a great job of getting more and more education out there so that folks can understand the benefits of mass timber construction. I think the other thing about getting to cost competitive or cost negative is really understanding and embracing the simplicity of it. And what I mean by that is when you think back to a lot of architects, engineers, builders, in some way probably got into the field because they play with Legos or Lincoln Logs or Tinker Toys or Erector sets or you name it, right? It goes back. And those are basic building blocks, right? Simple things put together in simple ways. Now, I'm oversimplifying mass timber, but it's a physical, visible structure that is an assemblage of parts that can be standardized. And the more you standardize, the more cost competitive it will be. So right now, the cost premium comes for a variety of reasons, right? Every manufacturer, domestic and foreign, has slightly different ways that they approach things. So one of the things that we have to do when we try to level a bidding field there is to customize the design for each manufacturer that we go out to. So rather than sending something out that is generic and then having SmartLam or Binderholz or KLH or whomever, LF5, put in their product to match the grids and the spacings that we gave them, we can actually run through our design algorithms and optimize the structure for their product. Now, that's because each manufacturer has slight nuances, like their preferred lamella layups or preferred panel widths. I mean, you talk about, like, for instance, Binderholz, like they can make you up to a 12-foot panel, but their most cost-effective one is a 4.1-foot panel. Okay, so what does that mean for when we do our layups? When we're working with you on the neutral project for vanilla, like, and we look at 4.1-foot layouts, what does that mean for the modules and for the layout? So those things, understanding what drives the cost on the manufacturing side is actually what helps you reduce the total cost of the erection side. And then secondly, when labor gets on board with mass timber, I mean, when we do a post-tension concrete tower, there's probably a crew of 50 folks, right, that are building that. And in Chicago, we probably build post-tension concrete faster than anywhere in the world, I would venture to say. 2.5 day cycles, like floor to floor, 12,000 feet. We can get done in 2.5 days. You can do the same thing with mass timber, right? Now you go to somewhere else with concrete, let's say like Raleigh, North Carolina, and they're like a really long time, like 10 to 12, 14 days for one floor cycle. So now all of a sudden, like, mass timber could actually be really competitive in the Raleigh market, because if we can come in and do mass timber in 3 to 4 day cycles, whereas the concrete crew is taking longer, for whatever reasons, right? So understanding the local market and the labor market and how those go together. And I think, and I could go on and on about this, because like with tall mass timber, the lateral systems are typically cast in place concrete. The tolerance on that per ACI is one thing. The tolerance on timber is different. How those things come together. I think we need to have more cross-pollinated trades. So concrete crews have carpenters, all of them, right, that build a temporary structure and then fill it with concrete. What if we use mass timber crews to set that, or vice versa, concrete crews with their carpenters to set the core and the frame? Now you're not worried about 2 different trades meeting up together. You have sole ownership of that frame, and you're not fighting about tolerances and how things go up. And oh, by the way, you can actually iterate much faster. So those are all ways in which I think the costs will come down when compared to traditional methods of construction. But it takes educating the public and design community. It takes thinking critically about where the margins of opportunity are, and it takes designing very specifically for the knowns in the manufacturing space. Those are a couple of things that we found anyway.
Yeah, no, I mean, those are all valid points. I think that's what we're seeing as well. Once we get more kind of standardization, which we're going to talk about in a second here with industrialized construction, and also once we get like more adoption in the labor markets, especially between trades, I think we're going to see costs go down. One of the questions I had on mass timber, and we're working on some really tall projects like 30 and 50 story projects. And so sometimes I get asked, like, is mass timber safe? And they're not talking about fire. They're talking about seismic or wind.
Yeah.
And so from a kind of seismic or wind load perspective, like we have in Chicago and Milwaukee specifically, how do you design and engineer for things like uplift and shear load and lateral wind loads?
Yeah, great question. So, I've been at several of these mass timber conferences and spoken and been on panels just as you have as well, and I've been a part of tall timber. And I'll just say out of the gate, when it comes to tall timber, I am not a proponent that everything should be mass timber. Like, we shouldn't have CLT shear walls, and not every single component of the building should be mass timber, because 75% of the volume in any building, regardless of material, is in the horizontal slab, right? And that's true with mass timber as well. So if we think about that with a sustainability lens and say, look, I could make this building 75% more efficient with carbon sequestration and embodied carbon if I focus on that horizontal element, and now find alternate materials or ways to go with the vertical piece, right? Whether that's steel, concrete, some combination thereof. That's the first move. The second move is that, like, from a code standpoint, and keep in mind that anything more than 18 stories right now by IBC is beyond code, right? So when we're doing Atlanta at 20 stories, when we're doing other projects around the country that are taller than that, we have to go in for an AMMR approach, an alternative means of materials, to get approval with the city locally on an AHA level. And we found great success in doing that because we go in and we show them the science, not only from the fire standpoint, because I think that conversation people are finally understanding, what CHAR is and what that means, but actually from a total durability standpoint and what it looks like. So, for instance, I've been meeting with the city of Columbus over the last couple of months for a student housing project we're looking at there. That's 13 stories. And the cores and the stairwells are completely non-combustible. So they're cast in place concrete, so that we know that there is this completely non-combustible element. It's also very robust, right? So we can actually optimize that in a way that we would optimize a concrete building and really think through the formwork of the concrete core, how it comes together, how thin we can get it, how much rebar we can lean out of it. So the taller we go, the same thing has to begin to apply with regard to other vertical elements like columns. And I'll just sort of leave it at that and say that we're working on exciting things that could actually push that innovation much taller by using a hybrid approach, and yet still integrate timber. And so I'm excited about where that could lead us, because not because I want to keep going taller and taller and taller than mass timber, but I think that tall mass timber creates an innovation opportunity that will expand across the industry in other ways as well. So going tall for gravity is one thing. Going tall for lateral is another. And the concrete core approach works really well with lots of building typologies. I'm a bigger fan of using concrete than steel for the lateral system, mostly because I think there's going to be a natural overlay between the concrete core crews and the timber crews. So I think about like cross-pollination of trades. The iron worker doesn't have carpenters that work for them, right? The concrete crews do. And so I think that if we're going to find a way to get taller and optimize costs, it's going to be continue to use concrete cores. And those crews potentially could swing over and become frame crews, and they could also then swing over and become window wall crews because they use carpenters over there too. So I think you get the entire core and shell with carpentry crew if you think carefully about it. And so from a lateral standpoint, I guess one more thing I'd answer your question on, the taller we go, especially in residential, the more important it is to consider accelerations and wind tunnel tests. And, the dynamic properties of concrete and steel are very well known because they've been tested for a very long time. And so it's important for us to lean into this when we're talking about tall timber, especially super tall timber, as it relates to what are the dampening ratios? What are the accelerations of my system? What's the natural period of this? So if I want to optimize a core layout for strength, it's one thing, but for serviceability, for accelerations, all those other things that we think about in tall buildings, we need to understand interaction with the rest of the timber frame and how that does or doesn't dampen things differently. So that's a key component to what we're doing in our projects around the country. It's not limited to Chicago, Milwaukee. I know you didn't ask directly about, but on the seismic level, because wood is lighter than concrete and seismic forces are directly proportional to the weight of the building, we actually have lower seismic forces that get into the building because a mass timber tower is lighter than a concrete tower or steel tower. So there actually are some inherent benefits to mass timber in high seismic zones as well. Now, the connectivity is a whole other conversation. But if, again, we are back to a concrete core, which is very well known and how it performs in a seismic or a wind region, stick to that and find ways to wrap around that with timber. Again, the 75-25 rule in my book, like the 75% of the fiber in the horizontal slab, focus on that, change out the vertical elements, that other 25% of the building.
Yeah, I know we haven't touched on seismic, but have you been following the UC San Diego seismic testing?
Yeah. It's fascinating.
Yeah, I'm actually trying to get the professor and lead engineer who's been working on the podcast. So hopefully I get him on so we can talk about it. But I do think that's kind of the next big frontier. and really having tall timber work out on the West Coast specifically.
Yep.
But we'll leave that for another day. Hopefully another podcast. One thing we've talked a lot about is this idea of industrialized construction and really how the A&E architecture engineering industry is kind of broken, specifically in regards to real estate development and really multifamily and office development, I would say. I think there's definitely areas where the architecture engineering industry performs well when you're doing like really nice museum design and these really kind of custom things. Yep. But you're building similar buildings over and over again, and you're doing it in a way that's completely different, and it's almost one-off in this kind of unique fashion. I think you and I both agree that it needs to be reformed, and there needs to be a new paradigm. And so how do you see kind of the best way forward here in multifamily and office construction going into the next 5 or 10 years?
Yeah, we do agree 100% on this. Look, there are a lot of incredible bespoke projects around the world, often ones that get written up in magazines and are fun to work on. We've worked on some of those as well. But when you really try to talk about solving the housing crisis, you're not going to solve it with bespoke buildings. I mean, we do our share of high-end residential work that's maybe a little more bespoke, but if you're going to really solve the housing problem, you're not going to do it that way. Now, we don't want prison cells either. Like, we want things that find the right balance. And so I keep going back to this 80-20 rule, where if we can highly optimize 80% of any building in the grid layout, the componentization of it, the manufacturing of it, how those requisite pieces and parts come together, how we even erect it, and then 20% can be reserved for something special, those special moments. Like, that's one way to approach something that truly optimizes its layout, its grid, its opportunity, and still creates something a little different for each project. So as we think through, and you don't really have to go any further than going through any factory at any point, right? I mean, go through Toyota and what they've done with their car and their chassis, or go through Ford right here in the United States and like how they created this assembly line. Or for a while, I was a part of a modular construction company in Chicago, and they did some incredible work of getting these modules prefabricated, pre-built on the site. They were building a home, 2 homes a week, and erecting them in 4 hours. Really impressive work that they were doing. The challenge became finishing on site and where that went. And not to go into modular construction too far, but there are threads there that tie what was good about that. What was good about that was trying to iterate in the shop very quickly. What was difficult about it was translated into the field. So I think this is the opportunity we have, is to learn lessons from modular construction, volumetric modular, to think about field sequence erection things and how to position those two things in a way that really capitalizes on that process. And I think that's what, if you look at any industrialized manufacturing, again, back to the automobile industry and what they do, like switching out different parts and pieces, that's the way we need to think. We need to think like we are reinventing, the Lego brick for the real built world, not for toys, right? Like, that's the way we need to think. So whether it's columns, beams, panels, floors, all those pieces on the frame, and that's just talking about the frame and the enclosure. Now we start to talk about MEP systems and other things that start to lock into that in almost like a click-lock manner. Not to be too coy about that, but I really believe that's where we need to head. We need to standardize it in such a way that you could go to Home Depot and get mass timber components and connectors to build your shed or even your single family home or duplex or whatever. We need, and that would be like one product type. There'll be another product type that might be something that works with engineered wood product manufacturers, another product type that goes to super tall. So the more that we can standardize this process in the manufacturing, the better we can bring those costs down. And I think the more it pushes us. So back to your first point, I fundamentally believe that our industry is broken. And I don't say that lightly. I've been in it for 27 years. I enjoy all of the counterparts that I work with on the A, E, and C side. They're wonderful people. But sometimes we as designers tend to make mountains out of molehills, right? Or we make these very bespoke type projects rather than solving the common problem. Now, there's a lot of designers who are really conscious about that and working towards solving that. But But what I hate is when, a new project starts, we go through concept design, schematic design, design development. You get to the end of design development, like, oh, shoot, we're like 20% over budget. What are we going to do? And then you send the team back. They go to redesign it, come back and like, oh, we could do that. And like, okay, well, I need more money because it cost me more to design it. And now you're like not even sure if you're saving money. And so that gets back to how do you avoid that? And I think fundamentally, one of the ways you avoid that is by doing this new approach to early concept design that's very intensive, not just on the massing programmatic side, which is what I think what we're used to architecturally, but actually integrating engineering and construction early on. Because if you can lock down cost issues tied to different options, it actually is freeing, right? It gives a designer more flexibility by knowing what the rules are to stay within to make it work. So I think embracing the industrialization of design and manufacturing is really ultimately where we can create opportunity and I think, maybe make a difference in the way that we're going. The days are gone, and I want to go back to them where we had true master builders, that like a builder who actually was an engineer or an engineer who was a builder and embrace that. We've become so siloed in our industry. It's like, well, that's not mine. See ARC or, means and methods and there's reasons we have all those things. I'm not saying we shouldn't have those things. I'm just saying, can we step back for a minute, walk in somebody else's shoes, learn from them? Again, it's first world, third world, first world, or historic, new, historic. How can we learn from the modernization of the manufacturing process to help us get better?
Yeah. To your point about master builders, what do you think about getting back to that concept where it's like developer, builder, engineer, architect, all in one?
Yeah, I'm personally a big fan. I maybe in part because I am part builder by nature, although that hasn't been my business. I'm a big fan of design build. So a lot of our concrete projects that are most successful are the ones that we do design build because we know how that subcontractor wants to do or execute their work and we can design accordingly. I think the same thing is true in timber. I think there's opportunity. There are some people who are currently doing that, and I think they're having some good success at doing that. Think about StructureCraft, for instance, and what they're doing around sort of almost an integrated design, build, delivery approach. So some benefits there that you can see and learn from them. I think others in the industry as well. So I am a believer that is a great way to go. May not be for every project, but I think it certainly has a lot of promise.
Yeah, and I think, that's something that we've been exploring, I think, together as well. But I do think, to your point about like the finger pointing, which happens quite often on projects, especially when everyone is so siloed into architecture, engineering, construction. And it's really like, well, what's the actual issue? And how do we collectively solve it to deliver a project on time, on budget? Because really, like in my mind, that is what should be driving everyone, but it's not. It's like the value alignment has been, well, how do I hold on to my fee? How do I make sure I don't have too many hours spent the firm on this project so I can make a profit, which is fine. It's like these guys are running businesses at the end of the day, but someone's left kind of holding the bag, which quite often is the developer or owner, which like not the best for us or the investor. And so I think in the long term, to your point, like it needs to be reformed where it's more design build and there's more this kind of componentized system where it's like, okay, here's a set of parts that you can pick from and design within these boundaries. And it's like, you still have design, to your point. 80% of it can be componentized and 20% can be design. Like for vanilla, I think that's something really nice that we've done on the project you're working on, where it's like the structure is very componentized. The facade is somewhat componentized, but the brick is actually all done masonry, just like any other masonry project. And then there's a lot of nice customary carpentry details on the interior. So yeah, one of the questions I had for you on specifically on engineering is like, from an engineering perspective, I know you've done a lot of work with Interstice, which is now being rebranded and kind of merged into Timber, which maybe we can talk about here in a sec. But what, from a like engineering perspective, do you think you need to do more of to be somewhat more, I would say, componentized and industrialized in your engineering and construction?
Yeah. So that's one thing. So yeah, you mentioned Interstice. My business partner, Eric Gunther, and I started Interstice 2 years ago, and it really came out of us observing, specifically, I was observing on the Cleveland Intro project that we were doing, all of the inefficiencies that were happening, and designing for one manufacturer, but then wanting to go out and bid or procure parts from other manufacturers, and how could we change that process? And so that led us thinking, and Eric did a phenomenal job of developing design algorithms, scripts that allowed us to go out to optimize for different manufacturers. So that could be SmartLam, it could be Bender, it could be KLH, it could be whomever. And so that early iteration got us to cost certainty even before schematic design. So like 95% cost certainty even before schematic design. That was a massive game changer for us, and something that we saw our developer clients responding to very, very warmly, and contractors too, because they were like, whoa, wait a minute. You mean you can give me a full set of concept or schematic plans that I can be 95% accurate on cost for the frame, and it can be customized to 5 different manufacturers? Yep, that's what we can do. And so like rethinking how we design early, there's still a lot of work behind that, but to get to that milestone quickly was really important. And then the second thing was thinking through, and again, this is credit to my partner, Eric Gunther, his development of 4D modeling relative to ways that we can understand labor rates and effectivity rates for building pieces. So my friend and our client at Harbor Bay, James Litwin, and I were on the Cleveland Intro project working hard to see that thing go together. And he did a great job of measuring cadences of how many picks, and he and I would sit on the deck and think about ways to rig differently or get things built differently. And then that information we were able to feed into things like construction logistics and say, okay, well, what could that look like if we were to implement that? Now, when you give that level of schedule certainty to a subcontractor, not just the frame erector, but also the mechanical, electrical, plumbing, drywall, trim, appliance subs, everybody downstream from that, now you're actually making a difference, because it's been well proven that mass timber could be done 25% faster. But what good is that if nobody else is coming in behind that, right? So if you can't get your enclosure up faster, if you can't get your other trades in faster, then what was the point? Like, okay, you save a little money, a little schedule on the timber frame from maybe conventional construction, but if you didn't really save, we were talking earlier before the call about agile planning and Scrum. Like if you could get twice as much done in half the amount of time, then like you're really at a missed opportunity. So I think that as engineers at Forefront, at Interstice, which is now Timber, and we'll talk about that in a second, we really have found opportunity to harness both the EOR side as well as the logistics side.
Yeah. And I think this is like an early kind of catalyst into what we were talking about with industrialized construction, of really looking at, okay, not just the engineering, but how does the engineering affect pricing in regards to different manufacturers with their different requirements? How does it affect costing in regards to construction and schedule? And for our audience, maybe who don't know, if you have more picks, obviously, which picking is just picking CLT or glulam mass timber, then obviously your cost goes up and typically your erection time goes up. And if you have less picks, then costs go down and typically erection time goes down. So it's definitely something that's very nuanced, because a lot of engineers will just give a developer and construction manager a set of plans and say, go bid. And they're not really doing this iterative process where they're actually figuring out really what the fiber counts are for that specific manufacturer. So one of the cool things that Josh does is he'll actually look at not only what manufacturer are we going with, but then once they select a manufacturer, and Josh, correct me if I'm wrong here, you'll actually then do another iteration of the design to optimize for the lowest fiber count. And the fiber count obviously plays a huge role in cost of how much your mass timber will cost. Is that that's something that Eric built, right?
Yeah. And so that, yes. And not only for the fiber, but what else is controlling the number of picks, like you said, or like, for instance, our Resi projects, we want corridors to be fairly beam free if possible, so that we can run MEP systems down there and not have to have ridiculous number of penetrations through a 2-hour frame or even a 3-hour frame if it's taller. So being able to play with grids very quickly and pick what the controlling criteria are, right? So there might be an architectural constraint. So like one of them that we put in is we don't ever want a beam to be wider than a column. Why? There's a visual concern, but also just fit up and connectors and how that goes together. We might have floor to floor height constraints. We might have quarter width constraints, whatever those might be, but being able to tease that out and run that through. And so, yeah, Eric did an incredible job of building scripts that helped us do that on the Interstice and Forefront side, so that we are running that kind of data in all of our design work as EOR early on. And then, I kind of put my contractor hat on and think about how this is going to get built and how we can partner with our team members that are actually going and building it.
Yeah, That's awesome. Yeah, that's definitely a big reason why we like using you guys, because you're thinking about things other than engineering. So, okay, I want to segue into our last item here, which is timber. So I know Interstice is in the process of or has finalized the merge timber, but maybe tell us a little bit more about that, and then whatever you want to say, we can wait for another podcast.
Yeah, that sounds good. Yeah, so as mentioned, and this is really like a platform, a foundational history, right? I mean, everything we talked about in the last 45 minutes has been, 27 plus years of working through this, whether it's thinking about traditional engineering or construction, how it goes together. And so, as I mentioned, 2 years ago, we started Interstice, and the purpose there was to have another vehicle that could work symbiotically with Forefront that was applied research driven. So Interstice has had funds that come from grants, funds that come from fee services, ways that we can go out and iterate new ideas. And while we do that, we can implement that into the EOR side of things. So we got introduced actually through a friend, Ricky McLean, to Josh Oakley, who founded Timber, TMBR. You can learn a little bit more about Timber at timber.com, TMBR.com. And so Josh has become a great friend and a partner now, and just really offsets and complements what Eric and I were doing on the Interstice side. So now Interstice is officially Timber. So we are all co-founders in that entity. Forefront continues to do what it does and provide engineer record services that are symbiotically linked to a lot of the work that Timber is going to be doing for our clients and developers. So we're excited about that. And yeah, I couldn't be more excited about where we're headed. I feel like we just gassed up in a major way in terms of what we're bringing to the market, from small to, I'll say, super tall now. Like we used to say small to tall, but we're actually breaking down a building into requisite parts that we can get to market faster with. And I know a lot of people, and it sounds very ambiguous, and like I said, I mean, maybe Josh Oakley or I or Eric can come on in a month or two and talk a little bit more to your audience about what that looks like. We're in the middle of meeting with folks from groups like yourself on the development side, to private equity, to folks who are interested in a product play. And so I think that what we'll see over the next year or two is a seismic shift in how we deliver projects and what role products play in that. So rather than just designing for, and this could be broadened to any manufacturer, any kit of parts that can be pulled together. And that's what I'm excited about. So I know that's broad, it's loose, but I'm super excited about it. And I think that your listeners will be as well when they get a chance to see what we're doing. We're actually in the middle of submitting intellectual property. So once that's out of being under wraps, we can share more, probably another month or so, but we look forward to that day.
Yeah, I got to wait for the patent to come back.
Yeah.
Especially so we don't steal your idea. Josh had accused me of. So I think it'd be great if we can have maybe you and Josh Oakley and maybe Eric as well going. I actually haven't had more than one guest on the podcast, so that'd be fun.
Yeah. Yeah, you're gonna love that, and I can't say enough great things about Josh Oakley and all the work that he's doing. he's helped me. I mean, a lot of people do this, but he's helped me just become way better at what I do, and it's been wonderful. So
Awesome. Well, thanks for joining today, Josh. Great
Thanks,
stories and a lot of good information. So happy you came on.
thanks for having me on. Great to see you, Nate.
Yeah, you too. Thanks, Josh.
Take care. Bye.
At Neutral, we transcend the conventional notion of merely minimizing harm. We embrace a regenerative philosophy, seeking to create buildings that begin to contribute to the health of our planet. Each project we build gets us one step closer to this commitment, a living embodiment of practices that replenish and restore. We'd like to thank you for being part of this conversation. For more information, visit our website at neutral.us. Thanks again for tuning in, and we'll see you next time on the Neutral Podcast.